This is a video about chemical formulas. Chemical formulas are basically used to represent a compound. So for example, if I say sodium chloride, the chemical formula is NaCl. So it's using the symbols seen on the periodic table to name a compound. Since mixtures are not always for sure the same makeup, they're not always definite, they don't have formulas. And what I mean by that they're not always definite is you can make a mixture with 5 cucumbers and 2 tomatoes, but it also can be a mixture if you have 500 tomatoes and 15 cucumbers. It doesn't matter, it's still a mixture. Whereas to make table salt, you have to have 1 Na with 1 Cl. You can't all of a sudden have Na5Cl2. That doesn't make sense. Same thing for water. Water is always H2O. It's not H2O5. If you have H2O5, then you've got a new substance. It's not water. So because compounds have a definite makeup, they can get a formula that will always tell you how many atoms there are of each thing in the formula. So if you take a look at water's example seen down below here, if you notice there's a subscript, the little number. A subscript to the right of a symbol tells us how many atoms there are of that element. So if you notice we have hydrogen and oxygen, and the little 2 tells us that there's 2 atoms of hydrogen, and since oxygen doesn't have one, right, doesn't have a subscript, we actually say that there's 1 atom of oxygen. The 1 is invisible. So we have 2 atoms of hydrogen and 1 atom of oxygen. Let's look at the last example down below, NaHCO3. How many atoms of each element are there? There's 1 Na, there's 1 H, 1 C, and 3 O's. Let's take a look at these 2 different examples. In the first example, there's parentheses. And if you notice, there's a number 2 on the outside of the parentheses. So think about what you would do in math class. Hopefully you said you would take that 2 and distribute it, because that's exactly what you do in science as well. So there's 2 atoms of oxygen and 2 of hydrogen. How many BAs are there? Well, there's just 1 BA because it's not inside the parentheses. Now let's take a look at the second example. I put a big 5 in front of water. That means that there's 5 of these water molecules, 5 H2O. So what do we do when we count atoms? Well, I know that there's 2 hydrogen here, but there's also 5 times as many waters. So what we do is we take the big coefficient in the front and multiply it by the subscript. So 5 times 2 gives me 10 H's. How many oxygens? Just 5. Let's take a look at this example. How many magnesium atoms do I have here? How many oxygen and how many hydrogen atoms? Take a second and try to figure this out. There is 1 magnesium atom, and there are 2 oxygen and 2 hydrogen. So don't forget to distribute. What if I put a big 3 in the front here? Well, that means that there's 3 of these molecules, and now it changes how many total atoms I have. I have 3 magnesium atoms, and I have 3 times as many oxygens, but don't forget the 2, so 3 times 2 is 6 oxygens. And I have 3 hydrogens, but don't forget the 2, so 3 times 2 again is 6 hydrogens.